Automation with Python. Chapter 2. In this chapter, we will introduce some important fundamentals of Python programming language. In this chapter, first, we will talk about variables in Python and how variable names are related to memory addresses. In the second section of this chapter, basic data types will be elaborated, including numeric data types, like integers and floats, strings, and Boolean data types, true and false. As the string is a collection of characters in a specific order, they should be indexable. We can simply access the items, in fact characters, inside string data type by locating their indexes. Let's look at the my_str variable. Rocks are solid is the string data type that is assigned to the my_str variable. Each character occupies a single index, place even empty space in the string data types. There is an important point here. In Python, index always starts from 0 and continues up to the end of the last character in the strings. This is positive indexing. We can also access the elements using negative indexes. The convention for such an index is that the last item is indexed as -1.
Flow control refers to the way a program's execution path is determined based on certain conditions or user input. In Python, flow control can be achieved using conditional statements including if, elif, and else to make decisions based on whether certain conditions are true or false. For loops are used when you have a block of code that you want to repeat a fixed number of times. In Python, a for loop is used to iterate over a sequence of values such as a list, tuple, or string. We mainly use for loop to iterate over iterables like lists. As you see in the structure diagram, after for keyword, the index will be followed by in keyword, then the iterable name. Like other structures, the line will be indented if you have a colon in the previous line. In this example, we want to print each character of the string object separately on the screen. This Python code initializes a variable rock to the string value sandstone. The code then enters a for loop that iterates over the characters in the string rock one at a time. During each iteration of the loop, the current character in rock is assigned to the variable idx and then printed to the console using the print function. After printing each character, the loop moves on to the next character in rock and repeats the process until all characters have been processed. The overall effect of this code is to print each character in the string sandstone on a separate line. In this example, we have a carbonate list that want to do some operation like printing on screen in individual items of the list.
Introduction to Chapter 8, Practice Synthetic Seismogram. Welcome to Chapter 8 of Course 401, Automation with Python. In this chapter, we will dive into a practical application that is highly relevant for geoscientists in the oil and gas industry, generating synthetic seismograms. 811, Overview of Synthetic Seismogram Generation and its Importance. Importance of synthetic seismogram generation. 1. Integration of well and seismic data. Synthetic seismograms bridge the gap between well logs and seismic data, providing a means to accurately correlate and interpret subsurface features. 2. Identification of formation tops. By matching synthetic seismograms with seismic reflections, geoscientists can precisely identify key formation boundaries and horizons. 3. Enhanced geological interpretation. Synthetic seismograms facilitate a better understanding of subsurface geology by improving the alignment and comparison of well and seismic data. 4. Seismic calibration. They help in calibrating seismic data with well data, leading to more accurate and reliable subsurface models. 5. Improved exploration and development decisions. Accurate synthetic seismograms contribute to better decision-making in exploration and development by providing a clearer picture of the subsurface. 8.3 functions. 8.3.1 Read last file path. Function to read a last file. This function reads a last file, which contains well log data, and extracts specific logs such as sonic DT and density RVOP logs. The function uses the Lazio library to handle last file reading. This function smooths the sonic DT and density RUP logs using a moving average filter. Smoothing the logs helps in reducing noise and making the data more suitable for further analysis. Here's the function and a detailed explanation. Python have function to smooth logs. Def smooth logs, depth d window size equals 20. Explanation and interpretation of the presynthetic data plot. Track 1. Tops. Description. This track shows the formation tops annotated along the depth axis. The tops are labeled with their corresponding formation names, e.g., AM, PD, GP. Interpretation. The tops are key geological markers that indicate significant changes in lithology or stratigraphy. They help in correlating the well data with seismic data and understanding the subsurface geology. Track 2. DT and smooth DT. The cyan curve represents the original sonic log DT in microseconds per meter, merits per min, while the magenta curve shows the smooth DT log. Interpretation. The sonic log measures the time it takes for a sound wave to travel through the rock formation. Smoothing helps in reducing noise and highlights the overall trend in the data. Variations in DT values can indicate changes in rock type and porosity.